This is the third and final video for Math 1105 talking about exponential functions. So what we looked at in the last section or the last video was the number e. The number e has a lot of applications, but we're not going to talk about them in this video. We're going to talk about an application to just exponential functions, and that is compound interest. And so compound interest applies to interest that is earned on a balance that is compounded, meaning figured and added a certain number of times per year. So the formula for compound interest is A equals P times 1 plus R over N to the N times T power. Okay, you don't have to freak out about this formula. You will never have to memorize it, but you do need to know what all the letters mean. So A is our account balance at any time t. So A is our account balance. P is our principal. That's our initial investment. Okay, so let's say we deposit $500 into an account. That would be our principal. If we want to know how much we have after 10 years, that would be our A, our account balance. Now this is actually the number 1, so don't do anything with it. There's nothing to do with it. R is the interest rate. Be sure that that is given as a percent. Sorry, it is given as a percent. Make sure it is given as a decimal. You want to put it in as a decimal. So that will be given as a percent. We want to change it to a decimal before we use it. N is the number of times our interest is compounded per year. So maybe your interest is compounded once a year. The N would be 1. Maybe your interest is compounded every month. That would be 12 times per year. So your N would be 12. Maybe it's compounded every 4 months. So that would make your N 3. That's 3 times a year. So this N is the number of times per year it's compounded. T is the time, very importantly, in years. So if your time is 6 months, that means your T is 0.5. If your time is 18 months, that means your T is 1.5. So just be sure that you are expressing this in years, not in months. All right, so let's do the example we have in our notes, and then that'll be it for this section. So the example reads, Henry's grandparents deposited $500 into a college fund earning 3% interest compounded semi-annually. How much will be in this account in 18 years? That is a lot of information. Let's see how it pertains to all the letters in our formula. First of all, we're being asked how much will be in this account in 18 years. That would be our account balance. So that's the thing we're looking for. Let's call that question mark. We don't know, that's what we're trying to find. P is our principal. That's our initial investment. We see here that initially $500 was deposited in the account. This is just the number 1, leave it. R is the interest rate. It's given to us in the problem as 3%. You really want to write that as a decimal to put into this formula. If you put in a 3, that's 300% interest, and you will get a very wrong answer. So be sure you remember a percent means divided by 100. So if you put that in your calculator or you just move the decimal point over, our R here is 0.03. And then finally, oh, I'm sorry, not finally. Next is our N. Okay, we're told here the interest is compounded semi-annually. Semi-annually means 2 times a year. So our N here is 2. And our T is how long it's in the account. And so this one is in the account for 18 years. Now that we've got all those letters identified, our job is to put them into this formula and find out the part that's missing, our A. So let's put it in. Our P is 500. It's just the number 1. Plus R is 0.03, N is 2, N is 2 again, and T is 18. Okay, still feels like a lot. Do the little pieces you can one by one. I can multiply this pretty easily. It's 36. Put it in your calculator if you have to. I can divide this pretty easily. It's 0.015. So let's go ahead and replace those with the numbers that they are. Okay, now let's work on the parentheses. Our order of operations says to do this first. If we want to add 1 to 0.015, that's just going to be 1.015. So we've got the parentheses done. Okay, if we want to raise this to the 36, that's where the calculator comes in. So I'm going to do 1.015. Uh-oh, I put a 6. All right, so here's what's in my calculator right now, 1.015. And I'm going to use this button right here under the clear. It looks like 2/3 of a triangle. It's called a caret. 1.015 to the 36. And I end up with some number I have no interest in writing. I'm not going to write it. But what I am going to do is multiply that number by what it's supposed to be multiplied by, 500. Let's see what we get. We get 854, and since we're dealing in money, we'll call that 57. 854.57. Okay, now if you look at it, you'll notice that's not a whole lot of money that we earned in 18 years, but that will typically be the case. This interest rate is pretty low. We earned, what, $354.57 between 500 and this final amount. Just be careful. If you forget to turn this into a decimal and you put in a 3, this number is going to be huge and it's going to be wrong. So remember that most of these are going to be not all that big. We're not going to have a huge gain here. So if you notice that you started out with $500 and in 10 years you have $5 million, that's almost never right. Okay, so go back and look at your problem. Make sure you remembered to do this. Make sure you remember to divide by the n. Just check your work if you see something that looks kind of unusual. All right, now in your homework, let me talk about your homework. I have a problem at the end of the homework. It has to do with like a rat population or something. I might even have a growth problem in there. I think maybe, I can't remember. But I give you some problems in the homework where I give you an exponential function and just ask you to find some stuff out about it. All you're supposed to do there is substitute a number in for the variable. You do not, and unless it's one of these, a financial problem where we have the formula, it's not up to you to come up with the function. I've got it in the instructions, so all you should be doing there is looking at the function I gave you and substituting in the values. All right, and that does it for exponential functions.